Okay. So actually in last video I have tried to show you how to measure temperature using thermocouple with LabVIEW program. Okay. In this for measurement I have used Keithley DMM65 digital multimeter. So today I will just use this multimeter to measure temperature, same as previous, but in this video I will try to show how to save data in file. Okay, so we will just go some more forward for this measurement. So for doing this I am writing its LabVIEW program from beginning. Okay, so just go in measurement IO, go in visa and visa open, and again if you write some command for instrument, then we have to put visa write. If we want to read something from instrument, then we must have visa read. Okay, and to close all of these things we have to put visa close vi. Okay, now we will connect one by one, same as previous. This is error should be connected in the same way. Okay, for selecting instrument we have to make visa resource name as a control. So this will be control. Here in write buffer we will write some command for instrument to perform measurement. The command will be MEAS semicolon TEMP question mark. If we want to measure temperature, then we have to put command like this. And if we want to measure voltage, then we have to put command for voltage. Okay. Byte count, we can put it constant into 16. Message from instrument can be shown as integer. The measurement performed by instrument is measurement. This is this will be in string format, so I'm calling it temperature string. Temperature string. Okay. So now maybe the program is ready for a single time measurement. Just check it. This front panel. We can put one more thing here on block diagram. We can put an error indicator. If there is some error in our program, then it will pop up like a message. Let's come to the front panel. Now this is okay. This is the place where temperature will, we can see temperature from measurement of device. We can make it somewhat bigger. We can increase size of text. Okay, so let's perform. Let's select instrument. I have connected. I'm connecting instrument. This is our instrument. I have connected only single USB from my laptop, so I have selected this. Now run. So what we see, there is around 90 °C temperature is showing, but this is in form of exponential. We can convert it in the form of number as we usually write or see. and we have to select quick drop menu by pressing control plus a space bar, and here we search for string subset. Okay, and press enter. Now connect this wire, this output wire, to input of the string subset. Okay. Here we put 0 offset, creating constant, and length we will put constant and 16. Okay. So now again comes to the quick drop menu by pressing control plus space bar, and here put fractional exponential string to number. Means this vi convert any fractional string to just simple number. Now connect output of the substring in input, and we show here an indicator. So here the temperature will be shown in number, like I am renaming it temperature degree Celsius. Okay. Let's see on how it looks like on block driver. So how it look like on front panel. So this is it. We can also increase the text size. Okay. So now let's run program again. So it is showing here, it is temperature string, and here is temperature in degree Celsius. Okay. So in this form we want to record our readings of temperature. And this is block diagram of this programming. Last time what we have done is just to we have run this program continuously for continuous measurement. Okay. This program can be run continuously for continuous measurement. This time we will not run continuously. We will apply some conditions on these things. So what I want to do is just to put case structure here, a while loop. Okay. I'm putting all the measurement section in while loop. Okay. You can see by inserting these blocks in while loop, this run arrow is breaked. It is it cannot be run right now. So what we have to do, we have to put a stop condition here. So we are making it control. Okay. Now it can be run. So this is a stop button on front panel. You can expand this. Stop. Okay. So this is so what we can do, we can run program, and it will execute in same way, and when we want, we will stop from here. This way. Okay. So this program can be run and can be stopped. What we do, we can do one more thing. We can add some graph as we have added previously. So this is a graph, waveform chart. Put it here. Let's connect this graph to measurement section. So we wire this. Okay. Now this is This is not the time actually. This is not time. This is number of measurements. Okay. So we will run again. We can see. We can see variation of temperature. Okay. So we will stop. This is default setting of instrument that how many data should be taken in certain interval of time. We can change this property of instrument. Just stop it. Just we put if we want to take if we want to take readings in some interval, like what we do is just go in timing and wait until next. Okay. Just putting multiplier. This is value in milliseconds. So create it control. And we can create it constant. And 1000. Let's come to the front panel and this is reading per second. Okay, you can shift these things above. This is seconds per data point. Okay. This is it. So now we can run this program by our need. Suppose we want a single data point in 2 seconds, so we will put here 2 and run this program again. So this instrument will take measurement at interval of 2 seconds. You can see the process has been slowed. Okay. So this is the way when we can take measurements with time. So this is how we can instruct instrument to record, to spend some time in measurements. Now what we want to do, we want to just see variation of temperature with respect to time. So in this case, I have to put time on x-axis scale and temperature on y-axis. So in order to insert time, we will put just time and come to high resolution relative seconds. Copy this same thing outside the loop. Okay. Now what we will put this subtractor. This is numeric and then subtractor. We will connect this time in VI to subtractor. Yeah. put it indicator. This is elapsed time. Okay, I'm making it bigger. Let's see on front panel. This is, this is elapsed time here. Okay, we'll put it 0.5. So what we are putting, just array, bundle array. Append array. Replace with shift register. Replace with shift register. Connect this shift register with this bundle array. Make it constant. So these things will show reading of time during measurement when measurement is started as time goes on. Now we will remove this graph, this waveform chart, and broken wires on front panel also. So it is already removed. Now what we do is just we will put a bundle here. We will connect time from here to this bundle and temperature reading from here to this bundle. Okay, this is connected. No problem. Okay, we will put another type of graph on the front panel. This is not happening. This graph, XY graph. Okay. So this graph on x-axis will show time, on y-axis we are putting it temperature, we are making it temperature. Okay, this is not XY graph, this is temperature versus time graph. This is here, we will connect this to bundle. This is not connecting, so what error is there? This wire will not connect as such. What we have to do is we have to again put an array. And connect this reading to this array. Connect this to loop. Make it shift register. Put it here. Make it constant. connect this wire. No, not that much. It has been a little complicated, so we have to take some patience. We have to connect this. Okay. Now this is okay. This is connected. No. Okay, this is good. Now we can connect our graph like this. Now this will work. This should work, I think. Now let's try on the front panel. Running program. So here you can see time versus temperature. We have put seconds per data 0.5, means it will take 0.5 second during between two measurement, and on x-axis we can plot temperature, and on y-axis we can see on x-axis we can see time, and on y-axis we can plot temperature. Okay, this is the program. Now our next task is to save this data in file, in text file. Like if we have to run measurement for 24 hours, so we cannot keep watching all the time. So what we want to do is just to save all the data in a file. We will process it after. So for this we will just stop this program. To the file IO and write delimited spreadsheet. Connect this. We will again put build array. Array has been built. This is not the way I was doing this. And again this. Okay. And this is 2D data, so we will connect this in 2D data. Okay. So we can give location where we want to save the file. So we put file path as a control here. Okay, and let's come to the front panel, and this is a file path where we want to save the file of measurement. No, that's not. Put here. I am selecting in the name test temperature. What we will do is create a text file. We will name it test temperature versus time. Test temperature versus time. Okay. We will select it temperature versus time. Okay. We have selected the path where we want to show the data. Now we will run the measurement. And data is recording. It is started to record data. It has started to record data. Okay. let's see how this look like in file. Okay, let's come to the PC. Test time. So you can see that this is in the form of rows. This is not actually this is readable, but this is a very small number. And these are the very small number of readings. So we can figure out on top row it is time, and on bottom row it is temperature. Okay. So what we want to do is just to put these things in columns, then it will look better. So just cancel this, come to the programming part. We will select transpose. Okay, this will transpose the data, make it control, not control, make it constant. Okay, so and put this in true mode. So now again select the path where we want to save file. Again create another file, text file, test temperature versus time 1. Okay, it's okay. Now we select this. Now run the program again. So again it is recording data. Now stop the program. Let's see what we can see in what we can see in. So this is okay. This is in the form of rules. This has been transposed. We can put some headers on above. So for using this, we will modify our program like. I'm removing this file path for some time. Okay, we will put string constant. Here I'm putting this is string constant. So first string constant will be time. Okay, copy the same thing and paste again. This will be temperature. Okay. What we do again, array is build array. This thing in array, and now create again file IO delimited spreadsheet. Connect it 1D data. We are connecting this to this. Okay, and put file path here by creating it control. We have created all things, and now we will append to a new file, create it constant, make it true. We will again select the place where we want to save the files. New text file. time versus temperature 4. So okay, select, click OK. Now just run program again to see what happens. It's taking some data. This is stop. Now let's check the file. Is it saving or not? Not this one. Okay, this is 4. So here we can see header of row, time and temperature. So in this way, using this program, we can, in this way, using this program, we can take measurement, temperature versus time. Like we can measure temperature with time and save our data in form of file. So in today's video, I will stop. And this is from my side in LabVIEW